next transformation is a vertical stretch and compress. This is if we're multiplying, but it's on the outside of the function. So you can see all the different equations that we're going to look at here in a second. When multiplying the function by a constant value, the graph gets stretched or compressed. Vertically. So in other words, it looks like someone has, if you can imagine them standing at the origin and they grab ordered pairs and they pull them up towards the towards the y-axis. Sorry, pushed up either away from the x-axis or they pushed it below or above. But we're changing y values here. So the point. So we're vertically adjusting the graph. So to graph, we will multiply the y value of the key point by the value, in this case a, so the a is the number on the outside of the function. When we multiply the function by a negative value, the function gets reflected. Okay, so let's look at illustrations of this, starting with sort of the parent points for the cubed root. So it goes through negative 1, 1, 0, 0, 1, 1. And if you recall, this is where it's horizontally aligned instead of vertically aligned. It's the cubed root. Oh, sorry. Come back here. So I'll use the black to illustrate that. I'm going to use red to illustrate the 2. So if I double the y values, I'm doubling the y values. So if I double, let's see, 1, 1 is now going to be 1, 2. 0, 0 is the same, and again, negative 1, negative 1. If I double that y value, I get that. So it's a little bit, again, looks like someone's pulling the y values away from the x-axis. And then we'll do this. Like, whoa, it's backwards. What are you doing? Well, I'm aware of what's about to happen. 0, 0 isn't going to change. But at 1, instead of going up 1, I'm going to go down 1. And at negative 1, instead of going down 1, I'm going to go up 1. And then it looks about the same. So it has that same sort of vertical alignment. Again, mapping-wise, what's happening, and I'll look at this last example so you can kind of see what numerically what's happening here. The y values are becoming opposite with that. So the x values stay the same, y values become opposite. And so I can keep all the x's the same. And, oh, I did it again. That should be negative. Graph was good. I just didn't set my table up right. Alright, so instead of that being negative 1, that negative 1 in the y value is going to be opposite, so that's positive 1. 0 is going to be the same, because opposite of 0 is still 0. And opposite of 1 is negative 1. And those should correspond to the ordered pairs that I plotted. Alright, let's look at the absolute value. Absolute value, our key points would be negative 1, 1, 0, 0, 1, 1. Goes there, there, and it's the flat, looks like the V. Okay, I'm going to do the red. Again, I kind of looked at the negative one. Oh, that's just going to make it opposite. So the y values are opposite of what they originally are, so it still goes to the origin. And now it's backwards from it, so it looks like the letter X. And then in this case, 1/2. Now this going to be kind of tricky to see in that it still goes to the origin, but instead of going up 1, it's going to go up 1/2. Instead of going negative 1, instead of going up to 1, it's going to go up 1/2. So it's going to be a little bit of a wider looking graph. And let me do the mapping on it, the ordered pairs. So here we want x to stay the same and the y's are half as big. So our 3 x values don't change, but the y values, instead of going through 1, it'll go through 1/2. still goes through 0, and that goes through a half as well. And so graphically, that's what I should be seeing when I look at all of my ordered pairs. So now that we understand the basic components of graphing, we're going to combine these together into multiple graphs and kind of look at some strategies on how to handle that. Step one in dealing with more than one transformation is to first figure out what's the basic shape. What is it? Is it a parabola? Is it a line? Is it a cubic? Square root? Then we're going to find the horizontal shift, which is we'll represent with H, and a vertical shift we'll call that K. And then we want to figure out where the critical point, that vertex, where did it go in each of our shapes? You know, for the most part, it's 0, 0. Where did the 0, 0 move to in the picture? And then we want to use any stretch and compress to find any new key points. And then we want to connect all the points and just make sure that it looks like the basic shape. You know, if it's supposed to look like an absolute value, it should look like a V when all said and done. So let's take a look at some illustrations of this, starting with -2 parentheses x minus 3 squared minus 4. All right, what would our basic shape look like? Well, I know it should look like a parabola. And our critical points, we gotta think for ourselves here. So we got -1, 1, 0, 0, and 1, 1. What's going to impact the left to right shift? Well, the only thing that's going to change that is that -3. And so the 3 is going to move it right 3 units vertically. So what's going to make it go up and down? The -4 will make it do that. And then we move it down 4. And so where did our vertex go? So if you think we're starting at 0, 0, if I go right 3, so 1, 2, 3, and down 4, I'm now at 3, -4. And so that's where my new critical point and my new vertex should start at. So let's see if I can kind of figure out how this graph works. So here's 0, 0, 3, let's see, 5, 4, 3. Okay, so right about there. Oops, I did 3, 3. Okay, so that's 3, -4. And from there, I'm stretching all of my y values, -2. So there's a reflection there, but all my y values are going to be multiplied by -2. So if I go into my mapping idea, this might help me see visually what's happening here. My x's are all going to have 3 units added to them. My y's are going to be -2 times them -4. And that should give me a set of new points to look at. Alright, well, let's see. -1 plus 3, so I'm just going through my x's. -1 plus 3 gives me 2. 0 plus 3 gives me 3. And 1 plus 3 gives me 4. Okay, so those are my x values. And corresponding to the y's, I want -2 times 1 minus 4, which is -6. Then -2 times 0 minus 4, which is -4. We already plotted that. And then -2 times 1 minus 4, which is again -6. So I can kind of, from here, I can sort of estimate that's going to go down to -6 from there, and then it should look like a general curve. Okay, so as long as I can tell, either graphically or labeled correctly, the ordered pairs, then it clearly will look like you know what you're doing as far as these transformations go. Okay, next graph would be 1/2 square root of x plus 5 plus 2. So what would the basic parent look like? That's going to be our square root friend. Okay, and the square root we had going through 0, 0, 1, 1, and 4, 2. And so we can kind of think about mapping-wise, what's going to happen here. So anything going to change the x's? Yeah, it looks like, even though it says x plus 5, remember the x's are opposite what we see. So all my x values are going to be minus 5. And the y values, looks like I'm going to multiply that by a half and add 2. Okay, so my horizontal shift puts me at, so what's going to make it move left and right? That means it's left 5. Vertically, it's going to move up 2. So where would the vertex be now? Well, it was at 0, 0. And when it moved back 5 and up 2, that moved to negative 5, comma 2 would be my new point. And it's going to have a stretch or compress of a half. So the y values are going to be half as big as they initially started off. Now I can estimate that, or I can actually just figure out, based on my mapping, what's going to happen here. So let's see. X is it's pretty easy to subtract 5, I think. So I go 0 minus 5, I'm at negative 1. I'm sorry, 0 minus 5 is negative 5. Wow, maybe it's not as easy. 1 minus 5 is at negative 4, and 4 minus 5 is negative 1. And the y values would be, let's see, 1/2 times 0 plus 2. So that puts me at negative 5, 2, which is where we said that point would show up. And if I have 1/2 times 1 plus 1, I'm sorry, plus 2, that's 2.5. So I can see negative 1/2 and 2.5 puts me a little bit above, very tiny, barely tell. And then 1/2 times 1/2 times 4. Plus 2. Well, half of 4 is 2 plus 2, so that puts us at 4. So I should have another ordered pair at negative 1, 4. And I just need to curve those points and kind of make sure it looks very square root-ish. Let's take a look at another one. Okay, so what would our basic shape look like? It's a cubic, so I'd expect it to look kind of like that. It's got critical points of negative 1, 0, 0, and 1, 1. Let's see, what would our mapping be? The only thing that's changed in the x's is that it says x minus 1, but that means we're actually adding 1 to all the x values. That means we're going right 1. Vertically, we got a negative out front and the plus 5 at the back. So negative y plus 5 would be how all those y values are changing. So vertically they are shifting down, shifting up 5. And we've got a reflection, so it's not really a stretch or a compress, is it? But it is a reflection across so the y values are opposite of what they started off to be. And what happens to our vertex? Well, initially it was through 0, 0, but we moved right 1 and we moved up 5, so it moved it to 1, 5. So I can kind of estimate where that is right there. And again, I'm going to change all these ordered pairs. It looks like the x's we're just going to add 1 to. So negative 1 plus 1 is 0. 0 plus 1 is 1. 1 plus 1 is 2. And then I just need opposites. And so take the opposite of the y and then add 5. So negative 1 plus 5 puts me at 6. Negative 0 plus 5 puts me at 5, which is what we already said. So 0, 6 a little bit above it. And then negative 1 plus 5 puts me at 4. So 1, 4. And then I just need to make sure it fits the same pattern. So it kind of looks like a reversed S from what a typical cubic should look like.